everyone. So this is our final lecture for this chapter 1, which is we still focus on the second subtopic 1.2 indices, surd and logarithm. So at the end of the lesson, students should be able to solve equation involving surd, indices and logarithm. Okay. So last lecture we have focused on solving the equation involving logarithm. For this lecture, we are going to focus on indices and surd. There are three methods in solving index equation. So this is for indices. The first one is by comparing base and index. Okay, so we have to compare their base. If the base is the same, means that we can compare the index of the terms on the left and on the right. Now the second one, by taking log on both sides of the equation. Okay, so this is when the x as the index and then we don't have the same base. And the last one is by using substitution to get a quadratic equation. So this number 3 is only happen if we have more than 2 index term. Okay, so let's see how this number 3, 1, 2, 3, how we use these three methods. Example 1. Solve the equation. For question number A, 5 to the power of x equal to 1 to 5. B, 7 to the power of x plus 1 equal to 12. And then C, 27 to the power of x plus 1 equal to 9x minus 1. So let's do question A. So 5x, 5 to the power of x equal to 1 to 5. Every time you want to try to solve indices question, first of all, what you need to do is to determine whether we can change both into the same base or not. Same base. So is 5 and 1 to 5 related? Is 5 can change into the basic base? So 5 is 5 very basic. How about 1 to 5? Yes, 1 to 5 can be changed into base 5 also. Okay, 5 to the power of 3. Now, because we have the same base here, means that we have the same index. So we just have to equate the index. So comparing index, we get that x is equal to 3. So this is the first method by comparing the base and index. Okay. Now, for question B, we have 7 to the power of x plus 1 equal to 12. Now, can we change 7 or 12 into a base, the same base? No. 7 is the basic one. 12 also cannot be changed into base. It's not a complete square value. Okay, so what we need to do, we have to use the second method. So we put log on both sides. So we have log of 7 to the power of x plus 1 and log of 12. So we can use either base 10 or base e. Okay, for this one it's base 10 because we don't have any value putting here. Kalau base e, it will be natural log. Okay, so what is the next step? Our target is to get the value of x, right? So how to get x as the subject? So we need to bring everything other than x to the right side, right? So what we can do, before we bring this log 7, we have to make sure this x is changed into the coefficient. So we apply the third law. So the power law. So we bring the x plus 1 as the coefficient of log 7. So we have x plus 1 of log 7. Now we can bring the log 7 to the right side. So we have x plus 1 equal to log 12 over log 7. So log 12 over log 7, you can directly use your calculator. Sorry. Use your calculator with base 10, and then what we want is x only, so the final answer should be x equal to log 12 over log 7 minus 1, which is 0.277. So this is for question B. We use the second method, which is taking log on both sides. So let's see question C. C, 27 of x plus 1 equal to 9 power of x minus 1. So we just have only two terms. We can put one on left side, another one on the right side. So first of all, determine whether we can change this value, the base, into the basic base. How about 27 and 9? Are they related? Yes, they are actually with base 3. So 27 is 3 to the power of 3, 9 is 3 to the power of 2. So we can apply 3 on both sides. So after that, applying the rule of indices, 8 to the power of n, 2 to the power of n can be written as 8 to the power of n multiplied by m. So here we can get 3 to the power of 3x plus 3, and the right side we get 3 to the power of 2x minus 2. So by comparing, so we use the first method here, compare. Compare the base, we have the same base, so we compare also the index, we get 3x plus 3 equal to 2x minus 2. So we get 3x minus 2x, let x as a subject, is equal to x. Negative 2 minus 3 is negative 5. So we get the answer x equal to negative 5. Okay? Okay, can we use the second method? Can we use the put log on both sides? It also can, okay? Because if we put log on both sides, we still can find the answer. But usually we try to solve by using the first method first. If we cannot use the first method, then we move to the second method. Okay, so you have to be careful in using the method lah. So let's solve this example. Question A and B, solve the following equation. So we have 4x, 4 to the power of 2x minus 2 to the power of 2x plus 1 minus 35 equal to 0. And B2, e to the power of x plus e to the power of negative x minus 3 equal to 0. Okay, so what you need to do? We cannot just put one term on the left side, another term on the right side, right? Because we have 3 terms here. So what you need to do? So for this one, we have to use the third method. Okay, because we have more than 2 terms. If it's only these 2 terms, we can put one on the right side, another one on the left side. Okay, the same as question B. Okay, so these 2 examples, we need to use the third method. Okay, so for question A, so we have 4 to the power of 2x minus 2 to the power of 2x plus 1 minus 35 equal to 0. So first of all, we need to look at whether we can change into the same base or not. Usually it will be the same base lah, but we can solve the equation. So this 4 and 2 use the same base, which is base 2. So the 4 can change into 2 to the power of 2, right? And then Oh, it's not changing to base 2. So, it changed the second term 2 to the power of 2x plus 1 into 2 to the power of 2x multiplied by 2 to the power of 1, which is 2. So, this 2 to the power of 2x will be 4 to the power of x. And then, what it will be? So, the first term will be 4 to the power of, this can be written as 4 to the power of x to the power of 2. So, we want to let the 4 to the power of x as u. Okay, so we get u square minus 2 of u minus 35 equal to 0. So we have a quadratic equation here. So we can solve the quadratic equation, right, by using the calculator factorization. So 35 is multiply of 7 and 5. So we have minus 7 plus 5. So u minus 7, u plus 5. So we have u equal to 7 and u equal to negative 5. But we are not finished yet because what we want to find is the value of x. So we replace back the u with 4 to the power of x. So we get 4 to the power of x equal to 7 and 4 to the power of x equal to negative 5. So how to solve for these two equations? Can we use the same base? No. This is index form, right? We cannot use the same base. It should be base yang sama lah kalau nak guna same base. No, we cannot change 4 into 2 and 7 into 2. No. So, we need to use the second method. So, for the third method, we have to solve the x letter by using either the first method or the second method. For this one, we need to use the second method, which is taking log on both sides. Okay, so if you want to put log on both sides, we get log 4 of power of x and log equal to log 7. So this x will be the coefficient. We get x equal to log 4 equal to log 7. X log 4 equal to log 7. So x is equal to log 7 over log 4, which is equal to 1.404. The right side, 4 to the power of x equal to negative 5. If we put log on both sides, log 4 of x equal to log of negative 5. Log cannot take any negative value. Okay. So if you put this value into your calculator, there will be undefined or unknown. So we don't have any solution for this one. So we have only one solution for question A, which is x equal to 1.404. So another method that you can use, earlier I said that I changed this 4 into 2, right? So you can also change this 4 into 2 to the power of 2 of 2x minus 2 to the power of 2x multiplied by 2. Okay, so if we change, we will get this 2 to the power of 2 to the power of x to the power of 2 equal to 2 to the power of 2 minus 2 to the power of 2 of x. Right? So that's why we change this equal into 4 to the power of x of square minus 4 to the power of x only. Okay, so this one we need to use 4 lah. We cannot use 2. If you use 2, you will get many power here. So it will be hard to solve. Or here you can write down as 2 to the power of 4x minus 2 to the power of 2x multiplied by 2. So it will be harder for you lah. So that's why we choose 4 as the base. Okay. So this is an alternative which is a bit complicated, more complicated than the earlier one. So we have to be careful in finding the base that we need to use. Okay. Question B. So we have 2e to the power of x plus e to the power of negative x minus 3 equal to 0. So how about this one? So we have the power of negative x. How can we do with this negative x? So it's actually equivalent to 1 over e to the power of x, right? So how to solve for this one? We don't have square or anything. We cannot replace. So we can just let e to the power of x as u. Or directly we can multiply e to the power of x to eliminate the e on the denominator. Okay? So here we multiply e to the power of x on each term. So we get, it will be 2e to the power of x multiply e to the power of x, and then here 1 over e to the power of x multiplied with e to the power of x minus 3 multiplied with e to the power of x equal to 0. Okay, so e to the power of x multiply e to the power of x will be 2e to the power of 2x. X plus x is equal to 2x. And then e to the power of x divided by e to the power of x will be 1. So we get this equation. And now we can represent it as 2e to the power of x square plus 1 minus 3 of e to the power of x equal to 0. And then we can replace e to the power of x as one of the variable, any variable. Okay, why? Because we cannot directly solve it. So let u equal to e to the power of x. So we have 2u square minus 3u plus 1 equal to 0. Okay, this one is e to the power of x all square. By using the rule of indices, amn equal to am to the power of n. Okay, so now we solve the quadratic equation by using the factorization. You get 2u minus 1 multiplied with u minus 1. So your u is equal to 1 over 2 and u equal to 1. So we want to solve for the u because we want to find what is x. So replace back u with e to the power of x. What do we get? Okay, so let me clean this side first. So we get e to the power of x equal to 1 over 2, e to the power of equal to 1. So to solve for this one, we can either change into base, the same base or not. But because our base e is an irrational number, so we have to use log on both sides. So how to put log? It should be, yes, put log, we choose the natural log. So it's supposed to be natural log of x equal to 1 over 2, natural log of e of x equal to 1. So this x, both here, it will be the coefficient. And then by using the properties, natural log of e is equal to 1. Oh, the right side also need to put ln. Ln 1 over 2. Here is ln 1. Okay? Sorry. Forgot about it. We should put log on both sides. So natural log of 1 over 2 here. So we have x equal to natural log of 1 over 2 and x equal to natural log of 1. So use your calculator, we get negative 0.693 and x equal to 0. Okay? Okay, now we continue with the next part, which is solve equation involving surd. Okay. So the first step you need to do if you want to solve the surd equation, we have to square both sides. Always square both sides because our target is to eliminate the surd. To eliminate the surd, surd is square root, so we square it. Square both sides, not square each term. It's different between square both sides and each term. We don't have square each term. It's not mathematically correct. And then expand and simplify equation. Repeat step 1 and 2 if the equation involving more than one surd term. So after you square, you simplify. If you still have surd, means that you have to square both sides again. Use factorization or quadratic formula to find x. So somehow we cannot factorize, so you have to use the formula. Always check the final answer whether they satisfy the original equation or not. So you have to check lah. After you get the value of x, put the x into the left side of the equation and the right side of the equation. So whether it will be the same or not, we have to check lah. So let's do some example. Example 3, question A, B, and C. So let's do question A first. So A equal to square root of 2x minus 1. Surd of 2x minus 1 and then minus 5 equal to 0. So the tips here, you separate between the one with surd and the one without the surd. Okay, because after we don't have to square, we don't have to expand hard if you separate it. So if you not separate it, you have to square this. So it will be sed 2x minus 1 minus 5 multiplied with sed 2x minus 1 minus 5. So you have to expand many times. But if you separate these two terms, because the right side is only 0, so you will be set of 2x minus 1 equal to 5. So it will be easier when you are squaring it. So you get square root 2x minus 1 and square the 5, right? So you don't have to expand anything, just cancel out the square root here and then put the right side will be a value lah. So we get 2x minus 1 equal to 25. So directly we can solve that 2x equal to 26. So x equal to 13. So how to check? We put back the value here into the left side. So we get square root of 2 multiplied by 13 minus 1 minus 5. What do we get? This is left hand side, right? So we get 26 minus 1 minus 5. So 25 minus 5. So 5 minus 5 is equal to 0. So it is equal to the right hand side. So we have checked it. Then X is the correct answer. Nah? So for question B, set of 3x plus 1 equal to x minus 3. So the same as question A, we separate the one with set and the one without the set on the different side. Okay, so here directly we can square both sides. Nah? So square on the left side, we get directly 3x plus 1. The right hand side, we have to expand x minus 3 multiplied with x minus 3. So we will get x squared minus 6x plus 9 on the right side. The left side is 3x plus 1. Now, because we have square here, we have to make sure it will be in the form of quadratic. So everything should be on the left side because the right side should be 0. Okay, so we get x squared minus 9x plus 8 equal to 0 lah. Okay, this one, they bring everything to the right side. So the left side will be 0. So you just rearrange and the 0 will be on the right side. Lah. So we get 0 equal to x squared minus 6x plus 9 minus 3x minus 1. So it will be negative 9x. 9 minus 1 is plus 8x. Plus 8. And then we just swap. 0 will be on the right side. Sama je. Okay, so now we solve the quadratic equation. We get x minus 8, x minus 1 equal to 0. So x is equal to 8, x equal to 1. But we need to check. The same as the question A. We need to check whether it's true or not. So, after checking, so I don't want to show the checking. You can do on your own. I just show you the example. So, left hand side for the first one, when x equal to 8, we get 3 multiplied by 8 plus 1 is equal to 24. 24 plus 1, which is 5. Kalau right hand side, we get 8 minus 3, which is equal to 5. So, same value, so we can accept 8. How about 1? So, you have to check for 1 pula. Kita nak buat semua. So, check answer, we only accept 8. Why? Because 1 is not satisfy both left hand side and right hand side. Okay lah, I show. So, if x equal to 1, so left hand side we get 3 multiplied by 1 plus 1 equal to 4 plus 4. 3 plus 1 is 4, so equal to 2. Right hand side we get 1 minus 3, which is equal to negative 2. It's not equal to 2. Tak sama. Okay, that's why we reject the x equal to 1. Okay, reject the. So the final answer should be x equal to 8 je lah. Siapa yang tak check, memang akan bagi 2 jawapan, it will be wrong. Lastly, question number C. Square root of x plus 3 minus set of 7 minus x equal to 2. Okay, now we have set. Dua set ni. So, what is the tips? Okay, for this one, you can either separate the cert on one on the left side or the right side, or both on the left side pun tak kisahlah. Tapi you have to do 2 times of square. Tak apa, kita tengok ya, step by step. Here they separate the cert lah, because tak nak serabut-serabut nanti cert ada banyak sangat. So they put the 7 cert 7 minus x on the right side. And then what we need to do, the next step is square both sides. The first step, always square both sides. So the left side directly we get x plus 13. On the right side, we have to expand 2 plus cert of 7 minus x. Multiply with 2 plus cert of 7 minus x. So 2 multiplied by 2 is equal to 4. Cert 7 minus x multiplied by 2 is equal to, yes, plus 2 cert 7 minus x. Use the rule of cert. And then 2 multiply cert 7 minus x sama juga 2 cert 7 minus x. And then cert 7 minus x multiplied by cert 7 minus x will be 7 minus x. Okay, so after simplify, what do we get on the right side? We get 4. And then this together we can add up because we have the same cert here. So it will be 4 cert 7 minus x plus 7 minus x. Now, we still have cert inside the equation. So we have to separate everything with cert and everything without cert on different sides. So here we separate. We have 4 cert 7 minus x. Positive, right? So we bring everything on the left side. We get x plus x. Okay, there's something wrong here. It should be positive to x, right? And then 13 minus 4 is 9. 9 minus 7 is 2. So it will be plus 2, right? So check together. Let's check together. Okay, so it should be plus 2. And then we have to square both sides lah. 4. This 4 square. This 4 also need to be square. It's like AB 12n. So it will be AN B 12n. So we get 16. What do we get as the result here? After we expand, yeah, it will be 16 of 7 minus x. Yeah, 16 of in a bracket of 7 minus x. Make sure you have to multiply everything. It will be 4 squared and square root of 7 minus x squared. And then the right side will be 2x plus 2 squared will be 4x squared plus 8x plus 4. Okay? And then what you need to do, we have a quadratic form ni. So expand everything, put in a quadratic, right, in a nice quadratic form. The right side should be equal to 0 lah. So what do we have here? We get 4x squared plus 24x minus 108 equal to 0. Okay, don't forget to expand this. So how to solve for this one? Factorize. Use your calculator. Can we divide by 4 first? Yes, it should be x squared plus 6x minus 27. It will be easier for you lah to solve because it's multiple of 4. So simplify first and then factorize. Use calculator. What is 27? 27 is, what formula we can use? 3 and 9. Yes, 3 and 9. So 3 and 9 we get 6 lah. So minus 3 plus 9. So x plus 9, x minus 3 equal to 0. So x equal to negative 9 and x equal to 3. Don't forget to check. After checking, the answer we can accept is only 3. Check. Don't forget to check. Okay? So that's all for chapter 1. Means that this lecture is only try to solve the equation involving indices and cert. Don't forget to practice for the log also. Okay, that's all for chapter 1. You can try to finish all the tutorial question and also the miscellaneous question. Okay, so thank you class.